Hi, this is Ms. Butcher, and I'm going to explain the side-side angle ambiguous case for solving triangles, and we're going to do this using cosines. So here's an example. Side-side angle means I've got two sides and then the angle that's not in between them. So suppose I had this. I had 27 degrees and I had a 5 and a 4. So the 27 degrees is attached to the 5. The 4 can go anywhere, right? We don't know the length of this side yet, so I'm just going to draw it really long. And the thing is with this, that 4 could go over here too, couldn't it? So we could have two possible triangles with this, with the same pair of sides and same angle. We could also have a situation, if I had made it like 2 or something, where it wasn't long enough. No matter where we swung it, it wouldn't hit, and so we could have no triangle. So we could have no triangle, we could have 1, or we could have 2. The way you have 1 is if this opposite side is greater than, I don't have room to draw it, but if your opposite side is greater than your non-opposite side. But today we're going to talk about these two. Okay, so suppose this is the problem you're given. You don't know anything about this triangle. Just draw an arbitrary triangle. Let angle A be 27 degrees. Side A is opposite that 27, so it's 4. Either one of the other two sides is B, 5. But then opposite of that would have to be angle B. And then this would be angle C and side C. So we're going to plug these numbers into the law of cosines. The 4 is across from the 27 degrees. So we're going to say 4 squared equals c squared plus 5 squared minus 2 times c times 5 times cosine 27 degrees. And so if you look at this, this is a quadratic. Our variable is c, and we have a c squared, and then we have a non-squared term. So we're going to set this equal to 0. 4 squared is 16, c squared, 5 squared is 25. And then a lot of you guys are confusing this. This is all one term. So you're going to multiply negative 2 times 5 times cosine 27, and we get minus 8.91c. So when we set this equal to 0, our quadratic is going to be c squared minus 8.91c plus 25 minus 16, which is 9. So now I'm going to solve this quadratic. I'm going to find out where it equals 0. And you can use the quadratic formula. Factoring is obviously not going to work. Or you can graph it in your calculator, and this is what I showed you guys in class. So we're going to punch it into y equals, just like this. And then we're going to look at the graph right there. And yes, my calculator screen is kind of dusty. All right, so we've got our parabola. What we can see is that we have two positive zeros. So those two positive zeros are going to be the two possible sides that C could be. So we're going to write down what those are. Now in your calculator, let's go over the steps one more time of what to do. You're going to push second here, and then calc here, and it'll bring up this menu. And then we're going to choose 0. Once you do that, it's going to ask you for a left bound. And so it's going to say at the bottom here, left bound with a question mark. If we have to do this for each 0, but if we're going to do it for this 0, you have to go somewhere to the left of it. Anywhere along here, just arrow over, hit enter. It's going to say right bound. So now we need to go to the right of it. So anywhere over here, hit enter. And then it's going to say guess. So now arrow over as close to it as you can get, hit enter, and it will give you the exact value. I get 1.162. So that's one of our C values. Then you have to repeat the process. Second calc 0 again, and we're looking at this one now, so you've got to go to the left of it, and then it's going to say right bound, so go to the right of it, hit enter, guess, go to it, hit enter, and it'll give you that one as well. For this one, it's 7.749. So now we have two different triangles that we have to solve. We've got 3 sides, we've got 1 angle, so we just have 2 angles left. We need angle C1 and we need angle B1, and then we need angle C2 and we need angle B2. Alright, so here we have, I just pulled the triangle sketch back over here, and now we know, okay, so this could go this way or this way. C1 would be the shorter one, 1.162. C2 would be if it was this longer one. So we have to now solve for the other angles. Alright, so we're just going to split this up and do it twice. If we have the shorter one, we can use the law of sines now. We can say sine of 27 degrees over 4 equals sine of angle C1 over side C1, 1.162. And we get an angle C of 7.578 degrees. So that would be this little one up here. So that makes sense, it's little. Then all we have to do to get the other angle B1 is subtract from 180. So if I took 180 minus the 27 minus the 7.578, I get 145.423 or 422 degrees. That's obtuse, which that would be an obtuse angle. Alright, so now we need to do the other situation. So we just do it again. We say sine of 27 degrees over 4 equals sine of angle C2 over side C2, 7.749. And when we do that, we get an angle C2 is 61.581 degrees, which makes sense if that was that angle over there. Up here. And then all we need for angle B2 is to subtract from 180. 180 minus 27 minus 61.581 gives us 91.419 degrees. So now we've solved the triangles. We've got C1, there we go, C1 and angle C1 and angle B1. And then we have C2 and angle C2 and angle B2. And that's how you do that.